Right, here is one more example on variation of parameters. It looks very, very complicated and scary. T square y double prime minus t times t plus 2 y prime plus t plus 2 times y equals 2 to the t cube. Well, but it is actually a bit easier than the first example, because notice that here we are given that y1 equals t and y2 equals t times e to the t are solutions of the corresponding homogeneous equation. So which means that we do not have to solve the corresponding homogeneous equation. Now, maybe I'll just mention that in lectures we only covered methods to solve homogeneous linear equations with constant coefficients. So there are some methods for approaching equations with non-constant coefficients that we did not cover in class. The reason we did not cover it in class is because if you need to solve any particular differential equation, then most likely you're going to do it on a computer, so it does not really make a lot of sense to memorize a lot of different methods to solve differential equations. So I still covered variation of parameters because it is, well, basically because it is beautiful mathematics. But if for your work in physics or engineering you need to know how to solve something like this, I guess you just read the textbook and let me know if you need any help understanding the text. Okay, but in any case, so if we, by the way, or maybe, so another explanation for this is that maybe this equation, the authors of the textbook, they set it on purpose. So that there are some methods how to come up with complicated differential equations on purpose if you know the solutions. So I use it sometimes to write your midterm tests or exams. So, well, well, in any case, so the idea here is that we're supposed to solve this non-homogeneous differential equation, but we are given the two solutions of the corresponding homogeneous differential equation. So, which sort of makes our life easier. So, recall that we're looking for a particular solution in the form, so the particular solution is going to be in the form y1 of t times u1 of t times y1 of t plus u2 of t times y2 of t. I probably need to take some, where y1 is minus the integral of y2 times g over the Wronskian dt, and u2 is the integral of y1 g over the Wronskian. Yeah, I memorized it because I did it a lot of times, but you don't have to memorize it because in midterm test 2 is open book. But what is important is to understand what is y2, what is g, and what is w. So y1 and y2 in this case were just given. Now g is going to be the right hand side of our differential equation, only it is very important that the coefficient at y double prime is 1. Since it is not 1 here, it means that we have to transform our original differential equation so that the coefficient at y double prime becomes 1. So basically we've got to divide by t squared. So dividing our differential equation by t squared, we get y double prime minus t divided by t squared is 1 over t. So this is t plus 2 over t y prime plus t plus 2 over t squared y. Well, I guess we could try to simplify it further, like 1 plus 2 over t, but I'm not sure which form is going to be more convenient for further calculation, or even if we need to do it at all. So I'll just leave it as is. So 2t cubed over t squared is what is 2 times t. Okay? So now our differential equation is in the right form, so the coefficient at y double prime is 1. So we can apply variation of parameters, and now the right hand side is g of t. Now this is g. So what else do we need? So we need w, we need the Wronskian. So the Wronskian of y1 and y2 is the determinant, where the first row are our y1 and y2. So the first row is t and t times e to the t, and the second row is the derivative. So the derivative of t is 1, and the derivative of t times e to the t, we've got to differentiate it according to the product rule. So this is e to the t plus t e to the t. Okay, so now we've got to do the determinant. So this times this minus this times this. So it is t e to the t plus t square e to the t minus this, minus t e to the t times 1. So this cancels out. The remaining term is just t square e to the t. So the Wronskian of the two solutions is t square e to the t. And now we can apply variation of parameters. So now let's do u1 first. This is minus the integral. Yeah, and notice that in variation of parameters, we did not really care whether the coefficients of our equation are simplified or not, because coefficients do not appear in the variation of parameters, only the right-hand side. So which means that we shouldn't bother with the particular way of writing down the coefficients. So only the right-hand side is important. Oh, so yeah, now y2 is t e to the t. G is now 2t divided by the Wronskian, and the Wronskian is t square e to the t dt. So what do we have here? E to the t cancels out, t cancels out, so the remaining term is just 2 dt, I guess. So its antiderivative is minus 2t. So this is u1. Now let's do u2. So we have the integral y1. Our y1 is t. Then g is still 2t divided by t square e to the t dt. Okay. So what do we have here? So t square cancels out. So we have 2 over e to the t dt. Then division by e to the t is same as e to the minus t. So this is really nothing else but 2 times e to the minus t dt. And now we can find the antiderivative. This is just minus 2 e to the minus t. Alright, so which means that now our final solution is going to be the particular, so y is going to be our particular solution plus the general solution of the homogeneous equation, which is c1 y1 plus c2 y2. Okay? So let me write the particular solution in this form. So y, we have y1 and u1. So u1 is minus 2t, and y1 is, where is y1? Is t times t. So this is minus 2t squared. Plus u2 times y2 of t. So minus u2 is minus 2 e to the minus t times y2 of t. And y2 is t times e to the t times t e to the t. Okay. Plus c1 times y1 is t plus c2 times y2, which is t e to the t. Well, and maybe I'll simplify it a little bit further. So noticing that e to the minus t times e to the t cancels out, and the remaining term is 2t. So the remaining term is 2t. So it should really belong here, because we have constant times t here, and that constant n times t, of course, includes whatever t is there, right? So again, this term belongs to the solution of the homogeneous equation, so which means that we don't really have to mention it at all, right? So the final answer is minus 2t squared plus c1t. So again, I did not write minus 2t because this minus 2t is already included here. So plus c2t t. So, and this is the final answer.